All right, so we have some new vocabulary. A quadrilateral is any polygon with 4 sides. We talked about that when we went over polygons. A parallelogram is a special quadrilateral where you have both pairs of opposite sides are parallel. So the right and the left are parallel, the top and the bottom are parallel. Okay, we have some theorems about parallelograms. The opposite sides of a parallelogram are congruent. The opposite angles of a parallelogram are congruent. The diagonals of a parallelogram bisect each other. And consecutive angles of a parallelogram are supplementary. Okay, so what we have, opposite sides are congruent. So these two sides are the same length, and these two sides are the same length. Opposite angles are angles that are across from each other. So this angle is the same as this angle, and this angle is the same as this angle. And then the diagonals bisect each other. So if I have two diagonals, this length is the same as this length is the same as this length. And then the consecutive angles add up to each other, so the one loop plus the two loop angles would equal 180. Okay, so these will be the same, and then these would add up to 180, or these two, or these two, or these two. So any two corners on the same side add up to 180. Corners across from each other are equal. Here we have this parallelogram ABCD. E is the point where the diagonals are bisecting. AB and DC are parallel, and then BC and AB are parallel. So opposite sides are parallel. The opposite sides of the parallelogram are congruent, so AB is congruent to DC and BC is congruent to AB. Angle A is the same as angle C, and angle B is the same as angle D. And then AE, so that's this piece right here, is the same length as EC. And BE, that's this little piece, is the same as ED because they cut each other in half. And then consecutive angles add up to 180. So A plus B is 180, B plus C is 180, C plus D is 180, and D plus A is 180. So as you go around, any two on the same side will add up to 180. Which basically this is exactly the same thing I just drew, but written out. Yeah, any two angles on the same side. So if you're on the top, these two angles would add up to 180. Or if you're down here, these two, or these two, or these two, and then the ones across from each other are equal to each other. A and B do add up to 180. Because they're on the same side. But A and C would not necessarily. Yeah. Yeah, the only A and C will add up to 180 if you have a rectangle or a square, because then you have 90 and 90. But on any normal parallelogram, the opposite ones across from each other are equal, and any on the same side add up to 180. Here's the type of problems we'll be doing. We're going to use the properties to find x, y, and z. Okay, so let's just label it really quickly. Okay, I know that this side is the same as this side, and I know that this side is the same as this side, and that this angle plus this angle, because they're not the same, they're going to add up to 180. So first we'll find x. X is on my angles, and because they're on the same side, they add up to 180. So 4x minus 17 plus 6x minus 13 will equal 180. If they had been opposite each other, then they would have equaled each other. So much in this is like the parallel lines, where we had the parallel lines with the transversal. When you're talking about the angles, it's either they're equal to each other or they add up to 180. So I have 10x minus 30 is equal to 180. I'm going to add 30 to both sides, and I get 10x is equal to 210, so x would be 21. Then to find y, when they're on the outside, they're talking about the length of the side here, and this length is the same as this length, so these two are equal to each other. So 5y minus 6 equals 3y plus 4. Take 3y away from both sides. I get 2y minus 6 is 4. Add 6 to both sides. I get 2y is 10. Opposite sides are equal. Equal to each other, yeah. Yeah. I sure did. Thank you. That's what I was just checking to make sure you guys were paying attention. That would change this, 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 and that.
How did you know what equation to pick? Just tell me to find x, y, and z.
Yeah, because they're telling me to find x, y, and z, I have to find the two x's. I can't combine an x and a y. Does that make? Yeah. I have to use the two x's together. I have to use the two y's together. I have to use the z's. Yeah. Yeah. Or like if this was 3z plus 8 and this over here was, you know, like 96 or something, I'd still set those equal to each other. Yeah. Okay, so for the z's, these two sides are equal. So 5z is equal to 3z plus 8. Take 3z away from both sides. 2z is equal to 8. Divide by 2, so z is equal to 4. Yeah, so I did x, y, z. I did it in order that way. You don't have to do it in order that way. You can do whichever order you want. Yeah. So let me do something better. This side is the same length as this side. This side is the same length as this side. This angle will be the same as this angle. And this angle is the same as this angle. And the two angles that are not the same are going to add up to 180. ADC, let me get my pen back. ADC, that's ADC, that's this angle here. And ABC, that's this angle right here, are called opposite angles. Okay? Because they're across from each other. If they're on the same side, so if you were talking an angle ADC and angle DCB, that would be these two. Those are consecutive. Consecutive means coming in order as you go around the figure. Okay. If AC is 26, that's this entire length. EC goes halfway because they bisect each other. So I take it and I divide by 2. Okay. If they had given me EC and asked for AC, I would multiply by 2. So when you're talking about the diagonals, you'll either have this side equal to this side, or if you have part and you're trying to find the whole thing, you'll multiply by 2, or if you have the whole thing and you're trying to find part, you divide by 2. Okay, if DC, that's this length right here, is x plus 18, and AB, that's this length, is 3x minus 4, I want to find the length of DC. Okay, so first I have to find x, and I know that AB and DC are the same. So 3x minus 4 is equal to x plus 18. Subtract x from both sides. I get 2x minus 4 is equal to 18. Add 4 to both sides. Guys, shh. 2x is 22. Then divide by 2, and then x is 11, and we're most of the way there at this point. We found 11, but we're trying to find the length of DC. That's x plus 18, so we plug in the 11. So 29. And then I have that DAB, that's this angle right here, is 113. And I want to find ABC, that's this angle right here. What I know about these two angles is they add up to 180. So I'll take 180 minus 113. So 180 minus 100 is 80, minus 10 is 70, minus 3 is 60. When you've been doing it as long as I have. As soon as I get, darn it, a pen. The algebraic way to prove or find that a set of points is or isn't a parallelogram is to use the distance and slope formula to compare the opposite sides. We're not going to do that. We're going to graph it. Okay. I have a piece of graph paper. Pretend this is an actual piece of graph paper. I plot my points. 0, 0, 2, 4, 8, 8, 4, and 6, 0. Okay. So I have my points. What I want to do, in order to prove that this is a parallelogram, I need the distances between here and here and here and here to be the same. And the distance between here and here and here and here to be the same. Or I need the slope and the distance to be the same on two opposite sides. If I count from here to here and from here to here, that's the change in y over the change in x. Remember that slope is rise over run. Okay, so if I go up 1, 2, 3, 4, so I went up 4 and over 2. If I go this way, I'm going up 1, 2, 3, 4, up 4, and over 2. My slopes match. Now I need my slopes and my lengths to be the same. Doesn't this make a right triangle right here? And if I make a right triangle, the length of the hypotenuse, that's this part right here, is this squared plus this squared, and you take the square root of it. Remember a squared plus b squared equals c squared? Well, if this length here is the same and this length here is the same as this and this, isn't this length going to be the same as this length? So if I go up and over the same number of squares between the two sides, then that makes my lengths here and here also the same length. So yes, this is a parallelogram. And I did not have to calculate the distance formula or the slope formula for any points. I just count for two sides that the rise and the run are the same. If the rise and the run are the same, then the triangles that I can make out of that are the same, which makes this length the same as this length. So I have the same slope and the same length. And one of the ways we could show that a parallelogram was congruent right here. If one pair of opposite sides are parallel and congruent, then the whole shape is a parallelogram. So we only have to deal with that one set and just make sure you get the same triangles. And then you're done. Does that make sense? Does anybody want me to go through it the algebraic way with the distance formula and the slope formula? Yeah, okay. So this was point A, this was point B, this is C, and this is D. So I know that roughly my shape is going to be, okay, let me come in with a different color on that, with the green. My shape is like this, right? Okay, and I still have to prove the same thing. I have to prove that two sides are parallel and congruent. So I'm going to use the same two sides, AB. No, I have to show. In order to say, yes, this is a parallelogram, I have to show that two sides are opposite and parallel. I mean, congruent and parallel. So I need AB to be parallel to DC, and I need AB to be congruent to DC. Now, I showed that graphically already, but if we're not doing graphs, I have to use the distance formula to show that they're the same length. So I'm going to have to do that twice. And then I have to use the slope formula. Oh, x, that's x. I have to use the slope formula twice to show that they have the same slope. Okay, so AB, the distance is 2 minus 0 squared plus 4 minus 0 squared. So that's 2 squared plus 4 squared. So that is 4 plus 16, so that is the square root of 20. For DC, I have 0 minus 4 squared. That's my y's. I put the y's in first for some reason. Don't worry, it'll still be the same. So I have 4 squared, negative 4 squared plus negative 2 squared, which gives me 16 plus 4, which is the square root of 20, and they are the same length. Now I have to check the slope. So this part is good. They are the same length. For the slope of AB, I have 4 minus 0 over 2 minus 0. So that gives me 4 over 2, which is 2. And then for the slope of DC, I have 0 minus 4 over 6 minus 8, which gives me negative 4 over negative 2, which is 2. So that matches. So you can draw a picture and make the triangles, or you can use the distance and slope. You have to use both. Yeah, in order to do it this way, you have to do both distance and slope. So you'd have to do all of this, which is the same thing that we did with the picture. We just did it with a picture instead of with actual calculations. Does that make sense? So I found out that the slopes were the same because they had the same rise and the same run. And then because I was able to draw the right triangles with the same rise and run, which means the same length sides on the right triangles, I proved that the distance here was the same without having to calculate it, because if you have two right triangles with the same length legs, then the hypotenuse is the same.
Yeah.
So that's the two ways to do it. You can draw a picture or you can do the algebra. Right. We know that opposite angles are congruent, so x and y will equal, x will be 110 and y is 70. And then you can see that they do add up to 180 next to each other, because you've got 70 plus 110, 110 plus 70, 70 plus 110, 110. Okay, now, what we did not talk about, we have parallel lines with a transversal. The diagonal is a transversal, which means that this angle is equal to this angle, and this angle is equal to this angle. All right, so to find x, I need to find out this missing circle part, dot part, because those are the same. Well, I know that this whole thing plus 117 will equal 180. So if I take the 180 minus 117, I'll get 63. So this entire thing right here is 63. The whole thing. Okay. This part of it is 26. So to find this part of it, I'll take 63 and I'll take away 26. And I have 37 left. So this part is 37, which means that x is also 37. I should make those stars, not x's, so it's not confusing. And then opposite sides are the same length. So if this one's 31, then y is 31. Not too bad. I'll do a C with a picture and D with the algebra. Okay, so for the picture I have 0, 0, 1, 2, 3, 1, 2, 3, 4, 3, 4, 5, 6, 7, 0, and then 8, 9, 10, 4. So to get from this dot to this dot, I'm going up 4 and over 3. To get from this dot to this dot, I go up 4 and over 3. So yes, it's a parallelogram. Yeah, you just say yes or no. Okay, for D, I'm going to do the algebra. So first I'm going to find the distance between A and B. So I'll have 3 minus 2 squared plus 7 minus 6 squared. I'm going to write up here again. Distance formula. So that gives me the square root of 1 squared plus 1 squared, which is the square root of 2. And then, I still kind of need to sketch it to know which side goes with. It should be CD, but I'm just going to 2, 6, that's A, 3, 7, that's B, 5, 12, that's C, and 3, 11, that's D. So yeah, AB, AB, CD. So CD is another side. So I'll have 3 minus 5 squared plus 11 minus 12 squared, which gives me negative 2 squared plus negative 1 squared, which is 4 plus 1, which is the square root of 5. As soon as the distances didn't match, I don't have to find the slopes, because I need the slope and the length to be the same. So if one of them's not, then I can stop there. So because these don't match, my answer is no.
And if you were just to draw the picture,
Yeah, I would do the same thing I just did here where I count, and once I counted from A to B and D to C, it wouldn't match. Yeah. For some people. For some people, the math calculations are easier. If you don't like graphing coordinates, then this is easier.